Today we're going to be finding the volume of cylinders and prisms. And when we talk about the definition of a prism, it's important to note that this is any three-dimensional object where the front and the back of the object has the same area. So for example, if we look at a cylinder, the circle at the top and the bottom of the cylinder, or front and back if it's tilted, would be equivalent circles. Therefore, this would be a prism. A cube over here, or a rectangular prism, would be repeated in the front and back. Same way here. The top and the bottom of this shape, the front and the back of the shape, and the left and the right of the shape would all be the same. Therefore, this Xbox 360 would be a prism. So that's how you know I'm old, when I show an Xbox 360 instead of an Xbox One. Okay, so when we're doing the volume of a prism, we need to remember that the volume is what is filling the object. So if I dropped in water to this object and I wanted to fill it up with water, that would be the volume of the shape. The other way that you can think of it is if you imagine the front of this object being a rectangle, and we took that rectangle and we stacked more rectangles behind it and made it three-dimensional, that would be what creates the volume. So the way that I give the formula for volume is you take the area of one face. So in the example to the left, that would be the area of a rectangle. And we're going to multiply that times the three-dimensional measurement for the depth. So in this problem, we would do base times height to find the area of the front rectangle, and we would then take that times the depth that makes this rectangular prism three-dimensional. The other way you can think of that is for a cylinder. Imagine we have one singular circle, like a coaster that's sitting on a table. And if we take that coaster and we stack a few more on top of it, we're starting to create a three-dimensional object. And if we repeatedly stack that coaster up, we have now created a three-dimensional object called a cylinder. And we would find the volume of this shape by taking the area of one circle times the height of the object, as if we are the number of times we are stacking that figure. So let's start doing some actual math here. So for this figure, we need to take the area of one of the faces and then multiply times the depth. Now this is the net of this figure, which means if you look, since it's being repeated, we could take the area of any face first. Now I'm going to do the area of this piece right here as the front, and then going back this direction we will count as the depth. So the volume of this figure would be 3 times 3, and I would take that times the depth, also 3, going backwards. So I then have 9 times 3 is 27. The label for volume is going to be inches cubed, because if you notice, each one of these blocks inside of this Rubik's Cube is 1 cubic inch. So unlike perimeter, which is distance or 1 inch, area, which would be two-dimensional or square inches, this is 27 cubic inches. The other way to think of it is volume is a three-dimensional measurement, like you're watching TV, seeing things in 3 dimensions. Therefore, our label has to also be in 3 dimensions. For this figure here, we're going to do the same idea, finding the volume of this figure. To find the volume, I am going to do the front of the Xbox right here, which would be 18 times 5. And I would say that this front piece is being stacked 8 centimeters back. Therefore, I would do 18 times 5 times 8. 18 times 5 is 80. And so 80 times 8 would be equal to 640 cubic centimeters. And I'm going to get out my calculator, because even though I teach math, I wouldn't be the only person to ever make a mistake. And it turns out it is 90 times 8, so it should be 720. So there's my mistake. So this ends up being 90 times 8. So the volume is 720 cubic centimeters. So that is the volume of that Xbox. We can also work with triangular prisms. So we would find the area of the front triangle, which is base times height, but we're going to divide by 2 this time because the triangle in the front is half of a rectangle. We will not use this number 2 at all because it gives us the outside measurement of the triangle, but it doesn't help us find the area of the triangle. And we're going to take this measurement times the depth of 10. Well, 1 times 3 is 3. So that gives us 3 halves times, and I'm going to write this as 10 over 1, which is the same as 30 over 2, which is 15. Therefore, the volume of this Toblerone, which is the best type of candy in the world, is 15 cubic centimeters. And one last shape that we're going to work with today is a cylinder or a silo. And imagine this silo, once again, like we talked about, coasters on a table. So we need to find the area of one of the circles, and we are then going to multiply that times the height of the silo. For this problem, the area of a circle is equal to radius times pi. That's the area of a circle, and we take that times the height of 40 feet. Well, I know that radius times radius is 144 times pi times 40. And now, if you're working with a cylinder, you're almost always going to have to use a calculator. So I'm going to do 144 times 40, gives me 5,760, and we're going to multiply that times pi, which gives me 18,086. And this is going to be cubic feet. And that is the last object from this video. If you have any questions, or if you didn't get 3 out of 4 questions correct, you can either ask me, or you can try a retake on the video, which should be posted on the website.